Hello viewers. So in this class we are going to solve yet another important and conceptual problem from definite integrals, right? So here again we have to solve the integral involving the signum function, right? So viewers, uh, concepts in mathematics are very important, and once we know the concepts we can easily tackle a problem, right? So this problem is one of them, and here we have to use a lot of concepts, right? So let us see the concepts one by one, and then we can combine all these concepts to find out the value of this definite integral, right? So let us start. Now here let us take this integral as I, right? Now here if we look at this integral, then we see that the limits of integration varies from -3 to 4, and here we have the signum function, right? And inside this signum function we have a quadratic function, right? See, here we have x square minus 4 which is a quadratic polynomial, right? So now here let us first see the basic definition of signum function. So now we know that the signum of y, right? So the signum of y takes the value +1 whenever y is greater than 0, right? And signum of y is always 0 whenever y is equal to 0, and signum of y takes the value -1 whenever y is less than 0, right? So viewers, this is the basic definition of signum function, and here if we compare these two expressions, then we see that y can be taken as x square minus 4, right? So if we use y is equal to x square minus 4, which is a quadratic polynomial, and then we can write the definition of signum of x square minus 4 as +1 whenever y is greater than 0. So y is here x square minus 4, so x square minus 4 is greater than 0, and signum of x square minus 4 is 0 whenever x square minus 4 is equal to 0, and the signum of x square minus 4 is equal to -1 whenever x square minus 4 is less than 0, right? So here we can easily observe that we have two inequalities, right? So the first one is x square minus 4 greater than 0, right? And the second one is x square minus 4 less than 0, right? And here we have an equation that is a quadratic equation. So we have x square minus 4 is equal to 0, right? So what we will do, we'll try to find the intervals, right? So we'll try to find the intervals satisfying these three conditions, and here we can solve these three expressions or three inequalities, two inequalities and one equation in the following manner. So we can write it as x square greater than 4, right? So we have x square greater than 2 square, right? And here we have x square less than 4, so we have x square less than 2 square, right? And here we have x square is equal to 4, so we have x is equal to plus minus 2, right? So now we know from the theory of inequalities that whenever x square is greater than 2 square, or in general we can use x square is greater than a square, right? So whenever x square is greater than a square, then the solution is x belongs to the interval that is -infinity to -a union, then we have a that is plus a to infinity, right? So this is the solution of this inequality, right? So we are not going to find the detailed method here how to get this solution. So we are directly using the result, right? Similarly, here we have x square is less than a square. A is 2, so the solution is x belongs to the interval minus a to a, that is x belongs to minus 2 to 2, right? Because here a is 2, and similarly here we have x belonging to the interval that is minus infinity to minus 2 union, and here we have 2 to infinity, right? So this is how we have decided the intervals, and now let us plot these intervals on the number line, right? So now here we have this number line, and here we can take minus infinity, here we have plus infinity, and here we have 2 points, that is the first one is minus 2 and here we have plus 2, right? So we see that when x belongs to minus infinity to minus 2 and then 2 to infinity, then we have x square greater than 2 square, and when x belongs to minus 2 to 2, we have this interval, right? And when we have x square minus 4 is equal to 0, we have x is equal to plus minus 2, and these are the 2 points, right? So this is about this function that is signum of x square minus 4, right? So now viewers, this is all about this signum of x square minus 4, and let us now concentrate on the limits of integration, right? So here we have minus 3 as the lower limit and 4 as the upper limit. So minus 3, it lies somewhere here, right? So this is minus 3 and 4 lies somewhere here, right? So now we have here 3 intervals, right? The first one is from minus 3 to minus 2, the second one is from minus 2 to 2, and the third one is from 2 to 4, right? So now here if we compare these intervals with these solutions, then we see that minus 3 to minus 2, it lies in this interval, because here we have minus infinity to minus 2, right? And minus 2 to 2, this interval is here, and the interval 2 to 4, it lies here, right? That is from 2 to infinity, right? So we can also say that 2 comma 4 is a subset of 2 comma infinity, right? So now viewers, let us denote signum of x square minus 4 as phi of x, right? So here we are using this notation just for writing the expressions in a simple way. So we can assume, or we can write phi of x is equal to signum of x square minus 4, right? And now we have to decide the value of phi of x, which is the signum function, in these 3 intervals, right? So now let us first take this interval, that is minus 3 to minus 2, right? So minus 3 to minus 2, it lies in this interval, right? And this interval corresponds to this inequality, that is x square minus 4 greater than 0. So therefore the value of signum of x square minus 4 is equal to plus 1 whenever we have x belonging to this interval, right? So when x belongs to minus 3 to minus 2, it means this interval lies in this interval, right? So this interval corresponds to this inequality, and whenever we have x square minus 4 greater than 0, then signum of x square minus 4, which is phi of x, it will take plus 1 value, right? Now let us take the interval minus 2 to 2. So when x belongs to minus 2 to 2, then here we have x belonging to minus 2 to 2, and this interval it has come from solving this inequality, that is x square minus 4 less than 0. So phi of x will take the negative 1 value. So here we have phi of x is equal to negative 1, that is signum of x square minus 4 is minus 1. And when x belongs to 2 to 4, then here this interval it lies here, right? That is from 2 to infinity, right? So now this 2 to infinity has come from solving this inequality, and when x square minus 4 is greater than 0, then phi of x will take plus 1 value. So here we have phi of x is equal to plus 1, right? Now viewers, here there is one important thing to explain, that is we have x square minus 4 is equal to 0, so x is plus minus 2. So these 2 points, that is minus 2 and 2, are the points where we have to break the limit, right? Or in other words, where we have to break this integral I, right? So here we have split this integral as a sum of 3 integrals, right? So the first one is from minus 3 to minus 2, the second one is from minus 2 to 2, and the third one is from 2 to 4, right? So now we can write I as I1 plus I2 plus I3, right? So I1 is from minus 3 to minus 2, and here we have signum of x square minus 4. So signum of x square minus 4, we have taken the symbol phi of x. So here we can write phi of x dx, right? I2 is from minus 2 to 2, and here we have phi of x dx, and here we have plus 2 to 4, right? And here we have phi of x dx, right? So now when x it varies from minus 3 to minus 2, then phi of x will take the plus 1 value, right? So now I can be written as minus 3 to minus 2. Here we have plus 1 for phi of x, right? And phi of x is equal to signum of x square minus 4. So signum of x square minus 4 will take plus 1 value when x varies from minus 3 to minus 2, right? And then we have minus 2 to 2, and here we have phi of x, that is signum of x square minus 4. So when x belongs to minus 2 to 2, phi of x is minus 1. So here we have dx, and then we have 2 to 4, that is 2 to 4, and in this interval, that is x belonging to 2 to 4, phi of x will take positive value, that is signum of x square minus 4. So here we have plus 1 dx, right? So now we have these 3 simple integrals. So we have here x, the integral of dx is x, and limits are from minus 3 to minus 2. Here we have minus x, limits are from minus 2 to 2, and here we have x, and limits are from 2 to 4. So now we can simply substitute the limits here one by one, and we'll take the difference. So here we have minus 2, then we have plus 3, and here we can take negative sign outside. So we have 2 plus 2, and here we have 4 minus 2, right? And this is 3 minus 2 is 1, and this is 2 plus 2 4, and this is 4 minus 2 is 2, and 1 minus 4 is minus 3, plus 2 and this is minus 1, right? So viewers, the value of this definite integral is minus 1, right? So this is how we can solve this important definite integral. And viewers, here we have witnessed that a lot of concepts are required to find the value of a simple looking integral, right?